Okay, so this is cognitive evolution from a Piagetian perspective. And what we're trying to do, we've taken Piaget's stages of cognitive development, and we're looking at them from the point of view of evolution. The basic idea is since humans are the only species known to have achieved formal operations, and we evolved from other more primitive species, there would be a time in the past where formal operations didn't exist, or at least was not in the human line. And we're suggesting that that's about the dawn of civilization, and formal operations would have appeared about the same time. And part of the reason for that is Piaget's own description of the factors that bring one to achieve formal operations. But since we're looking at this evolutionary, the question that arises, is there a stage past formal operations? Now, within Piaget's own work, he says formal operations is the last stage. But that's partly because the problem that he set out to determine was how do formal operations appear? And so naturally, once he's found all the steps to formal operations, he sort of answered his question. And the separate question then is, well, if you look at it in evolutionary terms, you go through these stages, and there's no particular reason why there couldn't be a next one. And indeed, many scholars have proposed stages beyond formal operations. We're doing this independently, and then we should be able to compare what we've come up with what various scholars have come up with. But the question comes up is, what is a stage? I mean, how do I know whether something is a stage or not? Is it anything you want it to be? Or are there criteria that we could use? I mean, if it's anything you want it to be, then the question of whether there's a next stage becomes meaningless. So we're looking for some criteria, and one of them would be you take the accomplishments of a previous stage as building blocks, and those are the building blocks for what you produce in the following stage. For example, you can say, well, operations are achieved in the concrete operational stage, and then those are used in various combinations to create systems and theories, which are the accomplishments of the formal operational stage. And we're going to continue that trend and say, well, now you've got these systems, from formal operations, and these can be used to define structures which can be shared among different systems and give you insights as to commonalities among these different systems that were not apparent because of they appeared very different until you looked at the underlying structures. Now, I have briefly looked at some of the other suggestions for post-formal operations, and some people don't stop at one. I mean, they may have 4, or they may have 10 or 20 stages, and then proliferation of stages makes me think that they're using too loose a definition. And just to illustrate, when you're in a state, one of Piaget's stages, it's not like cognitive development stops while you're in the stage. There are, we call it intra-stage accomplishments along the way. And Piaget's tasks that he has his children and adolescent subjects perform get at various stages within levels within a stage. And so the question then becomes, how do you distinguish between what is a level within a stage, an intrastage level, and an interstage transition? And I'm thinking that, and there is not an issue, Piaget would agree that what I would call the structure stage exists, but he doesn't call it a stage, he calls it a movement, and there's he would not deny that it's extremely important, or that is basically where he's at. He's part of that movement. I think that's how he could put it without bringing up the issue of stage. And one of the things I thought of about a stage is it not only adds to previous accomplishments, but it does something to the accomplishments of the previous stage. And for example, you would have various areas of math which seemed independent, and suddenly they're now treated together as, because of their underlying structures, in a new subject or a meta subject called abstract or algebra or modern algebra. And you might think, okay, just to exaggerate the situation now, if you thought about what a professor would be doing in a mathematics department, you probably wouldn't have, a professor of arithmetic, or a professor of tic-tac-toe strategy, or a professor of triangles, right? Those would be such simple things, there's no point in needing a professor of that. And I think that's what's happening to the subjects that were independent subjects before the structure stage took its toll on mathematics. So part of what we're seeing is it's not just that this new area of mathematics appeared, but it's sort of pushing to the side or underneath or subsuming the areas of math that people were pursuing. Another example was, I think it was Hilbert's program to find a consistent and complete axiomatic statement of all the axioms in math, with the idea that those axioms would be sufficient to prove any true statement within the system. And then another structural advance was Gödel's theorem, where that's impossible. And suddenly this one program that many of the top mathematicians were working on intensely just had to fade away. In contrast with another program that happened in the 20th century, where they decided to identify all the different classes of groups, and that was also an intense effort, but that ended for a different reason. That is, the goal was accomplished. So we see on the one hand major parts of classical mathematics, formal operations falling to the side, and because of the effect of the structural, the work of the structuralist in mathematics. Likewise, Einstein's relativity, which is structuralist, relegated. Newton, before Einstein, Newton's mechanics was basically considered the truth, and they were just working out the details of it. And after Einstein's theory of relativity got accepted, Newton's mechanics became relegated to a good enough approximation for slow speeds and reasonably large sizes. Another interesting sort of contest between formal operations and structure. Karl Popper wrote The Logic of Scientific Discovery, which is his formalization of the scientific process. And, you know, he was an eminent science, you know, maybe philosophy of science guy. And then Thomas Kuhn came along, who was clearly a structuralist like Piaget. He wrote a book called The Structure of Scientific Revolutions. And he basically had a sociological view of how science progresses. You have one group of people that believe one thing, and another group of people come to believe something else. And it's not like everyone comes to agreement on everything. There'll be a certain number of people that hold on, and certain people maybe transfer to the new system. And eventually the holdouts just sort of die out and become extinct. And that's how you move from one paradigm to another in Thomas Kuhn's view of science. And Karl Popper read that and said, oh, that's ridiculous. You know, it's all, you know, testing of hypotheses and all this other stuff. This is how you do science. And that's how things are decided, not by these popularity contests. And he offered to debate Kuhn, which I believe Kuhn accepted, but said, you know, I don't necessarily think debate does any good. And of course, if you're formal operations and you think that everything can be systemized, you do believe that debate is something that can resolve issues. But if you're Thomas Kuhn and you see the world as having completely different paradigms, and not only are the lower level contents different, but the higher level contents, like mechanisms for resolving disputes or disagreements, those are also different in the two systems. And the communication, you know, people tend to talk through it past each other when they're in different paradigms. So I don't think anybody's name was changed through this back and forth, but the importance of the back and forth is it shows that both on a substantive level and then on a meta level, there are differences, and it's the structuralist that recognizes that as the situation, and the person that with informal operations, as brilliant as they are, cannot see that you cannot resolve the disagreement through debate or any simple formalized procedure. So, in conclusion, what I'm saying is that if you look at the what I would call a transition between formal operations and structural operations, or structure, not only does the structuralist point of view add to the body of knowledge, but it takes away and undermines, in a sense, the importance of what were the greatest achievements of formal operations. And instead, you begin to see those achievements in a new light. Either they were probably, you know, just approximations, or they're misguided assumptions about the way things worked. And so in my mind, the fact that it can sort of take over and defeat, that the structure stage can, in a sense, take over and defeat the formal operation stage, would be a clear argument in favor of considering it a separate stage. Thank you very much.